So we're going to do dehydration synthesis. Dehydration meaning to remove water. Synthesis meaning to build. So we're going to build a polymer by the removal of water from two monomers. Okay, so the first step that we have to do is we have our two monomers here that we have to identify what they are. So we do that, if you remember from the slideshow, by looking at the left side hydroxyl group. So our hydroxyl group is OH, right, our OH group, and on the left side it is down below. Is that what? So we say that the hydroxyl group, since it's down, we say it's glued down like glucose. Glued down like glucose. So we have to identify the monomer, the second monomer. We do that again by looking at the hydroxyl group on the left side. That hydroxyl group is also glued down. So that is also glucose. So now we essentially have to dehydrate by removing a water molecule, and we do that by finding the two hydroxyl groups that are closest to the plus sign. And we never, ever, ever touch the hydrogens that are alone closest to the plus sign. We only remove from the hydroxyl groups. So now you're going to see how that looks, how it's drawn, and how that water is removed. So we take the hydroxyl group from one side closest to the plus sign, and a hydrogen from the other hydroxyl group of the other glucose molecule. But very important, we have to show that water leaving. Now it doesn't matter which hydroxyl group I take and which hydrogen atom I take from the other hydroxyl group. I took the hydroxyl group from this side, but I could just have easily taken it from this side, and I'm going to show you that in just 1 second. Sorry. Okay. So I could just have easily taken the hydroxyl group from this side and the hydrogen from this hydroxyl group over there. But very important that for any assessment for full credit, you have to show that water leaving. So now if you look, whatever's in that red is gone. Essentially, it's gone. It left as water. If you look, what is left is the oxygen atom. So essentially, I'm going to show you where that oxygen joins these two monomers to form a polymer. So normally, if you are writing on a paper or showing us how dehydration synthesis occurs, you would draw your yield sign, the arrow, and you would draw your polymer next to that. But due to space, I'm going to draw my arrow down here to show my polymer, just so I have enough room to draw it. So I start by drawing my ring structures of my two glucose. And I draw the outermost atoms attached to the ring. So I have my hydrogen atom, which I took from right here. my hydroxyl group, which I took from right here. It's very important that you remember to have this bond here only attached to this oxygen and not to the hydrogen, because if you remember, hydrogen's only one electron. It can only make one bond, which it's bonded to that oxygen. So now you're going to draw the right side of your second glucose molecule in the same orientation that it is up there. Hydroxyl group, and then hydrogen. That goes to there. And then my hydrogen atom is there. So now, since we're joining those together, how we do that is your oxygen that you're left with here, as your water has left, is going to replace that plus sign. And the two hydrogen atoms that we did not touch, you are just going to draw where they were. So your next step is to draw the lines where your hydroxyl groups were before the removal of the water. So I had one hydroxyl group there, so I draw a line going that way. My second hydroxyl group was here, so I draw my second line going that way, and then I just connect those lines to the oxygen atom. So one of the products of this reaction is now our polymer, and the second that we must remember to include is the water. And lastly, we must name this polymer, and since we know from our slideshow previously that you've seen on carbohydrates, glucose plus a glucose is maltose. And you also, you know what, I'm going to put that below. For full credit, you must also name your water.